Openstax College Algebra. This video covers Chapter 2.2 Linear Equations in One Variable from the Openstax College Algebra textbook, which you can download for free at openstax.org. We will solve equations in one variable algebraically, solve a rational equation, find a linear equation. Given the equation of two lines, determine whether their graphs are parallel or perpendicular, and write the equation of a line parallel or perpendicular to a given line. An example of the type of problem we're going to solve is this one. Caroline's a full-time college student and she wants to go on spring break. To earn enough money for the trip, she's taken a part-time job at a local bank that pays $15 an hour. She's opened a savings account with an initial deposit of $400 on January 15th, and she's having her pay directly deposited. If spring break starts March 20th and the trip will cost $2,500, how many hours will she have to work to earn enough to pay for her vacation? A linear equation in one variable is the equation of a straight line written with just one variable, in this case x. The only power of the variable that's allowed is the power of 1. Linear equations in one variable usually take the form ax plus b equals 0. There are three types of equations: identity, conditional, and inconsistent. Before we talk about those, I want to define a solution set, and that consists of all the values that make the equation true. If the equation is an identity equation, it doesn't actually matter what variable, what value you plug in for x, it's always true. All values of the variable are true. The equations we are most concerned with are conditional equations, and they are true just for some values of the variable. So if we look at 2x equals -8, the only value that makes that a true statement is x equals -4. So the solution set is just one number, the set containing the value -4. Finally, there's something called an inconsistent equation, and it results in a false statement no matter what you do. So it's a badly formed equation in the first place. So the equations that don't want to see for the most part are identity equations. They don't tell us anything. And inconsistent equations, they're false. Example 1, solve the following equation. 2x plus 7 equals 19. So we want to isolate the variable, and the first step will be to subtract 7 from both sides, which will leave us with 2x equals 19 minus 7, that equals 12. So we subtracted 7 from both sides. And now we need to divide both sides by 2, or we can multiply both sides by 1/2. Either way will result in x equals 6. So I'm going to say multiply both sides by 1/2 because that's the reciprocal of the coefficient, which is 2, and that gives us x equals 6. And of course we could check this. We know it's true because 2 times 6 plus 7 does equal 19. In example 2, we are solving an equation algebraically when the single variable appears on both sides. We're going to solve the following equation. 4 times the quantity in parentheses x minus 3 plus 12 equals 15 minus 5 times the quantity x plus 6. The way that we do that is to distribute. So that is 4x minus 12 plus 12 on the left side of the equation, 15 minus 5x, and -5 times 6, 5 is -30. Next, we're going to combine like terms. So this becomes 4x, and this is going to be -15 subtract 5x. Next, we will add 5x to both sides. So that gives us 9x equals -15. And what we're doing there is it's called isolating the variable. And that just means put all the x terms on one side. Now divide both sides by 9 or multiply both sides by the reciprocal of the coefficient 1/9. So that's x equals negative 15/9. So that means x equals negative, well, we can simplify this. We could use the calculator, or we could notice that that is negative 3 times 5 all over 3 times 3. So x is equal to negative 5/3. So the final step is to write the equation in simplest terms, and you're not done until you have done that part. Now we'll talk about rational equations, and these are equations where there is a variable in the denominator of at least one of the terms. And the way we handle these is we perform algebraic operations to get the variables to appear in the numerator. And of course, everything has to be an equivalent operation, and we do this by finding the least common denominator. Example 3, solve the rational equation 7 divided by 2x subtract 5 divided by 3x equals 22/3. And our first step will be to find the least common denominator, and the denominators are 2x, 3x, and 3. So the factors there are 2 and 3 and x, so the least common denominator is 6x. So we're going to multiply both sides of this equation by the least common denominator. So 6x times 7 divided by 2x, subtract 6x times 5 divided by 3x equals 6x multiplied by 22/3. So this is going to simplify to 3 times 7, subtract 2 times 5 equals 2x times 22. So this is 21 minus 10 equals 44x, or 11 equals 44x. I'm going to flip these around. So 44x equals 11, divide both sides by 44. X equals 11 divided by 44. So in simplest terms, x is equal to 1 multiplied by 11 all over 4 multiplied by 11. That's going to be a factor of 1. So x is 1/4. Of course, if I wanted to kind of double check myself, 11 divided by 44, go to math, output as a fraction, and I see that I'm correct. Example 4, solve the rational equation 2 divided by x, subtract 3 divided by 2 equals 7 divided by 2x. So the least common denominator here, well, the denominators are x and 2x. So the least common denominator here will be 2x. So I'm going to multiply everything by the least common denominator, and this will have the effect of removing the variables from the denominator. So 2x times 2 divided by x minus 2x multiplied by 3/2 equals 2x times 7 divided by 2x. So in this case, I have 2 times 2, and in this case, I have, as that's going to subtract 3 times x equals, this 2x will leave me with 7. So I have 2 times 2 minus 3x equals 7, or 4 subtract 3x equals 7. So now what I'm going to do is I'm going to choose to add 3x to both sides, so I have a positive 3x. And I'm also going to subtract 7 from both sides. So when I do that, I get 4 subtract 7 equals positive 3x. And that gives me negative 3 equals 3x. So x is equal to negative 1. So if I had to write the solution set for this equation, then I would have the curly brackets and the number -1 inside the curly brackets. Example 5, solve the following rational equation. 1 divided by x equals 1 divided by 10, subtract 3 divided by 4x. So in order to find the least common denominator, I want to make sure I include all the factors. So x is factored, that's everything, right? 10 is 2 times 5 if I divide it into prime factors, and 4x is equal to 2 times 2 times x. So I would need the factor x, I would need the factors 2 and the factors 5, and I've got 2 2's here, so I would also need this factor as well. So that means the least common denominator is going to be 2 times 2 times 5 times x, or 20x. Multiplying both sides of the equation by the least common denominator, I get 20x multiplied by 1 over x, so that's just 20, equals 20x multiplied by 1/10, so that's 2x, subtract 20x multiplied by 3 divided by 4x, so that's going to be 5 times 3. So this leaves me with 20 equals 2x, subtract 15. So if I add 15 to both sides, I will get 35 equals 2x. Flip that around, 2x equals 35. This is usually a mental step because it doesn't matter which way the equal signs go. So x equals 35 halves. Before I start example 6, I want to talk to you about dividing by 0. We cannot divide by 0. So if I said the number 3 divided by 0, this is not defined, it's undefined. Now let me explain why that is. Multiplication and division are inextricably linked. They're married, and it's a Catholic marriage, and the Pope married them. So if I say 5 times 2 equals 10, then that also means at the same time that 10 divided by 2 equals 5. So if I started the other way around, I could say 20 divided by 5 equals 4. So that also is going to mean that 5 multiplied by 4 is going to equal 20. Multiplication and division are inextricably linked. If I said 8 divided by 0 equals some number or other, that must mean then that 0 times some number or other equals 8. And this is, you can see this is nonsense, right? That just cannot be true. You can't multiply 0 by a trillion billion and get 8. So you cannot divide by 0. In example 6, we're asked to solve rational equations and state any excluded values. In part A, I have 3 divided by the quantity x minus 6 equals 5 divided by the quantity x. So I can see the excluded values here are anything that make the denominator 0 because we cannot divide by 0. So when x equals 6, that will result in 3 divided by 0 because 6 minus 6 is 0, so that's not okay. And then when x equals 0, that will result in 5 divided by 0, and that's not okay. So my two excluded values are x equals 6 and x equals 0. So I see that the least common denominator is the denominators. It's x multiplied by the quantity x minus 6. And if I multiply that on both sides, it looks like I've cross-multiplied, but actually this is really what I'm doing. Cross-multiplication is just a shortcut. So these will cancel out, or cancel really just means a factor of 1, and these will cancel out a factor of 1. So this will give me 3x equals 5 times x minus 6. So that's 3x equals 5x minus 30. let me subtract 5x from both sides. So minus 5x from both sides. And I will get negative 2x equals negative 30. I can imagine that I multiply both sides by negative 1, but this just becomes positive. And now I'm going to multiply both sides by 1/2. So I will have x equals 30 multiplied by 1/2, or 30 divided by 2, that is 15. So the solution is 15, and the excluded values are 6 and 0. So in part B, we have x divided by x minus 3 equals 5 divided by x minus 3, subtract 1/2. So in this case, the least common denominator is going to be 2 multiplied by x minus 3. So I'm going to multiply everything by that, 2 times x minus 3. And this will be 2 times x minus 3 multiplied by all of that, 2 times x minus 3 multiplied by 1/2. So that'll be a factor of 1, and that'll be a factor of 1, and that'll be a factor of 1. And I will have 2x equals 2 times 5, which is 10, subtract x minus 3. That's going to give me 2x equals 10 minus x plus 3. Or 2x equals 13, subtract x. So I will add x to both sides, that is 3x equals 13. Multiply both sides by 1/3, or divide both sides by 3. X equals 13/3. And I have to exclude the value of x that makes the denominator 0, which is x equals 3. So once again, the solution is 13/3, and the excluded value is 3. In example 7, we want to solve the rational equation after factoring the denominators and state the excluded values. So 2 divided by quantity x plus 1, subtract 1 divided by quantity x minus 1 equals 2x divided by quantity x squared minus 1. So we will notice that we have factors when we're looking for the least common denominator. The first factor is x plus 1. The second factor is x minus 1. And the third factor we have here is x squared minus 1, but that actually will factor to be x plus 1 multiplied by x minus 1. So the least common denominator is this, x plus 1 multiplied by x minus 1. So when I multiply every expression, both sides of the equal sign, by the least common denominator, x plus 1 multiplied by x minus 1, this is a factor of 1, so I can cancel it. This is a factor of 1, so I can cancel it. This is a factor of 1, so I can cancel it. And I'm going to clear out the fractions. So that's going to leave me with 2 multiplied by the quantity x minus 1. Subtract 1 times the quantity x plus 1 equals 2x. So you see that has the effect of eliminating the denominators, or eliminating the fractions. So when I distribute, I have 2x subtract 2 minus x minus 1 equals 2x. Now I will combine like terms, so 2x minus x is just x, and negative 2, negative 1 is negative 3 equals 2x. So if I subtract x from both sides, I'll have negative 3 equals x. Of course, that's exactly the same as x equals negative 3. And the values I will have to exclude are all the values that make the denominator in the original equation 0. So I have to exclude negative 1 and 1. The most familiar form of the linear equation is called the slope-intercept form. And that is written as y equals mx plus b. M is the slope and b is the y-intercept, or the point where the line crosses the y-axis. Now we use this formula to find the slope of the line. M equals y2 minus y1 all over x2 minus x1. So this is called the rise, how far it goes up, over the run, how far it goes along the x-axis. So this is up the y-axis or down, and this is along the x-axis in the denominator. In example 8, we are asked to find the slope of a line given 2 points. And the first point is 2, -1, the second point -5, 3. And it actually does not matter at all which point we label x1, y1. So I'm going to call the first point x1, y1 because that's the first point I've come to. And the second point x2, y2. And I'm going to use that formula for the slope of the line, and let's calculate it. So m equals y2 in this case is 3, subtract y1, which is -1, all over x2, in this case it's -5, subtract x1, which is 2. So m is equal to 3 plus 1, so that is 4, all over -5, -2, or -7. And we wouldn't really write it that way. We'd make the whole thing negative, so -4/7. In example 9, we are given an equation and asked to identify the slope and the y-intercept. And we're given the equation y equals -3/4 x minus 4. And you remember that we were given the slope-intercept form as y equals mx plus b, where m, of course, is the slope and b is the y-intercept. All right, so that means it's pretty easy to read. So it must be that the slope is -3/4 and the y-intercept b here is -4. Notice, because this equation is plus b, so we'd have to think of this as y equals -3/4 x plus -4 in order to put it into this format so we can see what's what. Often we see a problem where we're given 1 point and the slope of the line. And in that situation, we use the point slope formula because we've got a point and a slope. And that is y minus y1 equals m, the slope, multiplied by the quantity x minus x1, where the point is x1, y1. The slope is m. So in example 10, we're asked to find the equation of a given line, given the slope and 1 point. So we're told that the slope of the line, m, is equal to -3, and the line passes through the point 4, 8. So the point would be x1, which of course in this case will equal 4, and y1 in this case will equal 8, because our point is 4, 8. So we will have to use our formula. So the formula y minus y1, so y minus 8, equals m, which is -3, multiplied by x minus x1, which in this case is 4. So now we just have to distribute and solve this equation for y. So we have y minus 8 equals -3x plus 12. I'm just distributing here, and then I'm going to add 8 to both sides. So I have y equals -3x plus 20. And here's the equation of the line. Example 11 asks us to find the equation of a line that passes through 2 given points. Now in this case, we're also going to have to use the point slope form, but we're going to have to begin by finding the slope. So the 2 points are 3, 4 and 0, -3. I'm going to call the point 3, 4, x1, y1 and the point 0, -3, x2, y2. So to find the slope, I have m equals y2, which is -3, subtract y1, which is 4, all divided by x2, which is 0, subtract x1, which is 3. So the slope is -7 divided by -3. So the slope is 7/3. And now I need to use the point slope formula. And it actually does not matter which one of these points I call x1, y1. The equation will work out the same in the end. So I'm going to leave it the way it is. So I have y minus y1, which is 4, equals +7/3 multiplied by x minus x1, which is 3. So y minus 4 equals 7/3 x subtract 7. Because remember, 7/3 multiplied by -3 is just going to give me -7. So I'm going to add 4 to both sides. So y is equal to positive 7/3 x. And if I add 4 to both sides, this will be -3. There's another equation that is also representative of a line, and that is called the standard form of the line. And it is ax plus by equals c. A, b, and c are integers, and the x and y terms are on one side of the equal sign, and there's a constant term on the other. In example 12, we are given a slope and a point and told to write the equation of the line in standard form. So we have to start with the point-slope form and solve it until we get to the standard form. So the slope is m equals -6, and it passes through the point 1/4 -2. So x1, y1. And let's start with the point-slope form. So y minus y1, y subtract -2 equals a slope of -6, and x subtract 1/4. So that's going to give us y plus 2 equals -6x plus 6/4. So y plus 2 is equal to -6x plus 3/2. So what I'm going to do is I'm going to add 6x to both sides, and I'm going to subtract 2 from both sides. So I will have y minus 6x equals 3/2 subtract 2, which of course 3/2 subtract 2 is actually 3/2 subtract 4/2. So I have y minus 6x equals -1/2. So remember the standard form ax plus by equals c, where a, b, and c are integers, and I have this fraction here. So what I need to do is clear out the fractions, and I can do that by multiplying both sides by 2, because that's the denominator of the fraction, that's the least common denominator. So that will give me 2y minus 12x equals -1. And if I want to write it exactly in this format, I would write it as -12x plus 2y equals -1. And there is my standard form. So we've learned about sloped lines, and now we're going to talk about vertical and horizontal lines. So the equations of vertical and horizontal lines don't use any of the preceding formulas. If we see an equation x equals some constant, that is a vertical line where c is a constant. And the slope of a vertical line is undefined. So let's consider the vertical line x equals -3. So here's a point on that vertical line, and this point is x is -3 and y is -5. And here's another point on this vertical line, and that is x is -3 and y is 1. Now if I want to find the slope of this line, I'm going to call, it doesn't matter which one, I'll just call this one x1, this one y1, and we'll call this point -3, 1, x2, y2. And just to reiterate, -3, -5 is x1, y1. So finding the slope of the line, I have y2, which is 1, minus y1, so minus -5, divided by -3 subtract -3. And that tells me that m is equal to +6 divided by 0. But we cannot have that. This is a divide by 0, so that means this is undefined. The slope of any vertical line is undefined. Now we're going to consider the horizontal line, y equals -2. And there's 2 points that I've pulled out from this line, -2, -2. We'll call that x1, y1. And the point 0, -2, so we'll call that x2, y2. And now we'll find the slope of this line. So we have -2 subtract -2 divided by 0 subtract negative 2. So the slope of this line is 0 divided by 2. Now this is defined. It's perfectly all right to have 0 divided by some whole number on the bottom as long as that whole number is not 0. So the slope of the horizontal line is 0. So the slope of any vertical line is undefined and the slope of any horizontal line is 0. In example 13, we're going to find the equation of a line passing through the given points 1, negative 3, so let's call that x1 and y1, and 1, 4, so let's call that x2 and y2. So the slope of the line, m equals y2, which is 4, subtract y1, which is negative 3, all divided by 1 minus 1. So this is going to be an undefined slope, isn't it? It's m equals 7 divided by 0. An undefined slope indicates a vertical line. So a vertical line has the form x equals, well, there's only one value of x, isn't there? 1. So the line that joins the point 1, negative 3 to the point 1, 4 has the equation x equals 1. And as you can see, it has a vertical or upright line. The next idea is how to determine whether graphs of lines are parallel or perpendicular. Parallel lines have the same slope and different y-intercepts. So lines that are parallel to each other will never intersect. And here's an example. The blue line here is y equals 2x minus 3. So the slope here is 2 and the intercept is negative 3. In the second case, we have the line y equals 2x plus 1, and the slope here is 2, and the intercept is 1. And in the third case, y is equal to 2x plus 5. The slope here is 2, and the intercept is 5. Lines that are perpendicular intersect to form a 90-degree angle. So here in this example, we see this angle is they are 90 degrees to one another. The slope of one line is the negative reciprocal of the other. So that means if the slope of the first line is m1 and the slope of the second line is m2 and we multiply both of these together, we will get negative 1. So in this example, we have the line y equals 3x minus 1, so the slope here is positive 3, and in the second perpendicular line, y equals negative 1/3 x minus 2, so the slope here is negative 1/3. So I can call this slope 1, and let's call 3 slope 1 and negative 1/3 slope 2. Now we know they're perpendicular, we can see they're perpendicular, so if I do the multiplication m1 multiplied by m2, I will get 3 multiplied by negative 1/3, and that will equal negative 1. So I can see that these two lines are perpendicular because they meet the criteria that the slopes are the negative reciprocals of each other, and when I multiply them together, I get negative 1. Example 14. Graph the equations of the given lines and state whether they're parallel, perpendicular, or neither. The first line is 3y equals negative 4x plus 3, and the second line is 3x minus 4y equals 8. So I want to solve each of these equations and put them in the form y equals mx plus b. So the first equation, 3y equals negative 4x plus 3. I'm going to multiply both sides of this equation by 1/3, and that will give me the line y equals negative 4/3 x plus 1. In the second equation, I have 3x minus 4y equals 8. I'm going to subtract 3x from both sides, so that's going to give me minus 4y equals negative 3x plus 8. And I'm going to multiply both sides by negative 1/4, and that is going to give me y equals positive 3/4 x subtract 2. So I see the first slope is negative 4/3 and the second slope is positive 3/4. They're not equal to one another, so they're definitely not parallel. Let's see if they're perpendicular. M1 multiplied by M2 is equal to 4/3 multiplied by 3/4, and that equals -1, and that meets the criteria for perpendicular. So they are perpendicular. First, let's graph y1. In line 1, we have 2 points, x is 0, y is 1, and x is 3, y is -3. And let me graph that line. So there is line 1. In the second equation, we have y2 equals 3/4 x minus 2. So the first point is 0, x is -2. And the second point is x is 4 and y is 1. And there's the second line. And you can see the angle between them is 90 degrees or perpendicular. Example 15. Write the equation of the line parallel to 5x plus 3y equals 1 and passing through the point 3, 5. So first I want to find out what the slope is. So 5x plus 3y equals 1. I'm going to solve this for y. So I have 3y equals -5x plus 1. I'm going to multiply both sides by 1/3. And this will give me y equals -5/3 x plus 1/3. So the slope is -5/3. So if I want to write the equation of a different line passing through the point 3, 5, I have to use the point slope form. So I have to use y minus y1 equals m times x minus x1. And of course, this is x1 and y1 here. And here's my slope. So y minus 5 equals -5/3 x minus 3. So y minus 5 is equal to -5/3 x. And then what I'm going to have here is plus -5/3 multiplied by -3. So I have y minus 5 equals -5/3 x plus 5. Because the two negatives make a positive. I'm going to add 5 to both sides. So y equals -5/3 x plus 10. So I have two equations. This is the line that I started with, and this is a parallel line because they have the same slope. So here we can see the two parallel lines. They both have a slope of -5/3. Example 16. Find the equation of the line perpendicular to 5x minus 3y plus 4 equals 0 and passes through the point -4, 1. So I'm going to take the equation 5x minus 3y plus 4 equals 0 and solve that for y. So I'm going to add 3y to both sides. So I'm going to flip it. So I have 3y equals 5x plus 4. I did two steps in one. I added 3y to both sides and then I flipped it around. Then I'm going to multiply both sides by 1/3, and that is going to give me y equals 5/3 x plus 4/3. So the slope of this line is 5/3. Now if I want to write the equation of a line that is perpendicular to this line, then I have to have m1 times m2 equals -1. So I have to have 5/3 times m2 equals -1. And I'm going to multiply both sides of this equation by 3/5. That is the reciprocal of 5/3. And I see here that the second slope, the perpendicular slope, will be -3/5. Or I could just think about it. What do I have to multiply 5/3 by in order to get -1? And that would be -3/5. So this is the slope that I need. And here's the point that I need, x1 and y1. And I'll need to use the point slope form, y minus y1 equals m times x minus x1. So that's going to give me y minus y1 equals the slope, which is negative 3/5, multiplied by x, subtract x1. So I have y minus 1 equals negative 3/5 x plus 4. Y minus 1 equals negative 3/5 x. Minus 3 times 4 is 12/5. And now I'm going to add 1 to both sides. So y is equal to negative 3/5 x. Adding 1 is negative 12 plus 5, so that's going to be negative 7/5.